This video deals with quality criteria that are applied to both quantitative and qualitative samples. As discussed in the first session, three main quality criteria can be distinguished in quantitative research. First, objectivity, that is the independence of the empirical result from the researcher. Second, reliability, that is the fact that repeated studies lead to the same empirical result. And finally, validity. This means that the researcher measures what he or she intends or claims to measure. With regard to objectivity, three different types are of particular interest. These three types depend on the specific point or step in the research process. For example, it is important that a scientific study is conducted objectively. It is equally important that the empirical results are evaluated and interpreted objectively. Let's look at some methods to ensure the particular type of objectivity. With regard to the objectivity of implementation, it is recommended that the interaction between the experimenter and the respondents is minimized. This means that there should be as little interaction between the two parties as possible. It is also advisable to conduct so-called double-blind studies. Double-blind refers to the fact that both the respondent and the experimenter do not know the background of the respective study. This means that even the experimenter does not know what the research question is, what the hypotheses are, or, for example, what experimental condition the respondents were assigned to. In order to ensure the objectivity of the analysis, it is advisable for the empirical data to be evaluated in parallel by several researchers. This is particularly relevant if the analysis has a relatively large number of degrees of freedom, such as in the case of open text fields. To quantify the evaluation objectivity, the so-called kappa measure, or Cohen's kappa, can be calculated. The kappa measure shows how much the researchers agree on the parallel evaluation. This agreement is also known as inter-rater reliability. In conclusion, it can be said that it not only makes sense to have different researchers involved in terms of evaluation objectivity, but also in terms of interpretation objectivity. In other words, it makes sense that in this step too, the empirical evaluation is reviewed by different researchers in the context of the research question and the hypotheses. And only if these researchers answer the research question in the same way, the objectivity of interpretation is given. Furthermore, different methods can be distinguished with which the reliability of a test procedure can be checked. For example, a measure can be divided into different parts. If the scores of the different parts correlate highly, this would indicate a high reliability. This method is known as parallel test reliability. Further, a measure can just be repeated at a later point in time. This method is known as test-retest reliability. However, it may also be useful to check not only the reliability of the entire test procedure, but also the reliability of the individual parts of a test procedure. Imagine that we want to check the reliability of a test procedure, for example, a scale for measuring self-esteem based on 10 individual statements or 10 individual items. We could now develop an alternative scale and see if the same thing comes out. Or we could apply the same scale several times and see if the same things come out again. However, it is equally important to look at whether the individual parts of a scale or test procedure are trending in the same direction. This is called internal consistency. Here, each item is undergoing a parallel test, so to speak. The internal consistency is represented by the so-called Cronbach's alpha, that is the average correlation between the items. A Cronbach's alpha of at least 0.7 is considered sufficient, while a Cronbach's alpha of 0.9 and above is considered good. Different types can also be distinguished in terms of validity. In the case of criterion validity, a criterion is used with which a comparison is made. For example, a study on manual skills can be compared with the production of a manual piece of work. Criterion validity is only given if both measurements tend in a similar direction. Construct validity, by contrast, involves a comparison with other variables that measure the same or something very similar. For example, frugality can be compared with how often people go shopping at discounters. Finally, we turn to content validity. Content validity occurs when the measurements of a construct fully capture its content in all its aspects. Depending on the literature, content validity is also referred to as a partial form of construct validity. Content validity cannot be determined objectively with a statistical parameter, but is typically ensured with the theoretical approach.